Hello and welcome to Biolog's Odin Analysis Spotlight video series. Today, we are going to take a look at how you can leverage the Odin Community Analysis software package to learn more about the ability of soil microbes to solubilize inorganic phosphate and fix nitrogen, two key functions of the rhizosphere, and therefore make these nutrients available for uptake by plants using RhizoPlates.
RhizoPlates are an easy-to-use solution for quantitatively ranking microbial candidates or communities on their relative ability to solubilize inorganic phosphate in the case of RhizoPlate P, or their ability to fix atmospheric nitrogen with RhizoPlate N. RhizoPlate N is a great alternative to the commonly used acetylene reduction assay, which requires a high degree of training and the use of a GC mass spectrometer and dangerous acetylene gas. RhizoPlate P, meanwhile, replaces the qualitative PVK assay, which relies on difficult-to-make agar plates and measuring zones of clearing. Both of these assays give invaluable insight into the agricultural utility of candidates and communities, and also provide useful information about carbon source utilization, as each plate contains 30 different carbon substrates which can impact nitrogen fixation and phosphate solubilization. Today we'll be focusing on RhizoPlate P and phosphate solubilization, though RhizoPlate N uses the same software tools to assess nitrogen fixing. Here's an example of RhizoPlate P and a dataset you can get, which shows growth curves for strains which are known to solubilize inorganic phosphate or not. So we can see here that some samples grow more rapidly on RhizoPlate P and are therefore more proficient at solubilizing inorganic phosphate, which is their only way to obtain phosphorus in this assay. So let's take a deeper look now at the Odin software to learn more about the RhizoPlate analysis and how it can be used to rank candidates on their phosphate solubilization ability. So first, I'm going to select the project where my RhizoPlate data is stored. And then I'm going to pick our reference sample. In this case, we're going to use E. coli, which is known to not solubilize inorganic phosphate. And then I'll pick out our test strains. In this case, we're going to be using A. piti and P. petita, which are bacteria commonly found in the rhizosphere. Then I'll pick our plate type, and we'll hit Generate Charts to get things going. If we scroll down here and take a look at our average well growth development curve, we can see that the signal here is really low, and that's to be expected as inorganic phosphate is the sole source of phosphorus for these microbes, and it makes it very difficult for them to grow. So let's adjust the y-axis maximum here in order to better view our data and then regenerate the charts. Next, we need to look for the latest point where the growth curves first level off and then pick up again, which indicates when they ran out of stored phosphate and start using the exogenous or inorganic phosphate for energy. So here that looks to be at about 25 hours with E. coli, our negative control. So if we enter 25 hours as our x-axis minimum and then regenerate the charts, the software will automatically normalize the data and to remove all growth signal prior to the phosphate solubilization. And this allows us to rank our samples by which we're most effectively able to grow by solubilizing the inorganic phosphate. With our data normalized, it's really clear to see that A. piti, shown here in orange, was the most proficient at solubilizing the inorganic phosphate, followed by P. petita in green, whereas E. coli struggled to surpass the baseline, which is to be expected as it was our negative control. And finally, to give you a quantitative metric by which to compare these samples, you can also export the AWGD plot parameters, area under the curve, as a CSV file. I hope that this demonstrates how the RhizoPlates can be a great alternative to traditional methods for ranking candidates on their ability to solubilize inorganic phosphate.
Thank you very much for tuning in to this Odin Analysis Feature Spotlight. If you have any questions or are interested in trying this analysis yourself, please reach out to info@biolog.com. Or to find more Spotlight videos and other helpful information, please visit biolog.com.